Okay, this is chapter 23 in Withcott, Minerals and Mining. It is the last chapter in the book. So the case study is kind of interesting. It talks about mining for the minerals that we put in cell phones. And I just think you should read it and be aware that as a global citizen, you should be aware of like the consumption that you have and how that affects other people. Because we take it for granted that we can just go out and buy cell phones and things like that. But the minerals that are inside them come from areas like this where people have to work like this. And you should just be aware of that whenever you buy something. Then if we move on, the first section is on Earth's mineral resources. You should know the difference between a rock and a mineral. A rock could be made up of many minerals, but a mineral is a pure substance, if you remember that from chemistry. So it's a solid inorganic substance. It could be an element, could be a compound, regular crystalline structure. A rock is made up of all, it could be a bunch of minerals kind of conglomerated together or something like that, or it could have some other organic pieces in it and things like that. This picture is just showing you like a lot of things that are made from mineral resources. I think you guys know what things are made out of. We do obtain minerals by mining. How do they know where to mine? Scientists find ore, which is what minerals are, what they call the minerals that they're looking for, through a variety of kind of different things. They do seismic studies, which is when you shoot waves through the ground and study how they reflect back. They take rock cores, you just dig a hole, a narrow hole, and pull it up and see what's in it. They look at the magnetic field. So if you're looking for a ferromagnetic ore like iron, then you could look and see if there's a large magnetic field there. And then they can also do a chemical analysis of water. So as water goes past minerals, it can dissolve them, and you can look at what's inside the water and kind of assume what's above it. All right. On the next page, this is basically talking about extracting metals from ores and that we process the metals after mining the ore. So ore is like everything that comes up, and then you get the minerals out of the ore. So you have to either kind of break it apart and get the metal out, or you have to do some sort of chemical process that gets the metal out, or the mineral. It doesn't always have to be a metal. So you should know these terms. Metal, that's obviously anything on the periodic table that's in the metal section. Ore, which is, basically what I just said. Smelting is a process where you get the ore-bearing rocks and you get them to really high temperatures, and basically you melt the metal out of it. You should know what tailings are. This is a waste product for a mine. This is like when you dig up everything and you just kind of toss it to the side. I mean, that's not the greatest way of describing it, but that's kind of what it is. And then a surface impoundment. Surface impoundment is a water storage area. So something like this, where you put water over your tailings or things like that to try to keep it from blowing away. Okay. Have a map here, and it just kind of shows you where different minerals are mined and what they're used for. It's kind of worth looking at. And then you should think not all mining is for metals. A lot of it is, and we tend to think of it as being for metals. But we mine for sand, right? That's silicon dioxide, and we use that for semiconductors. We use it for glass. We use it for all sorts of things. Phosphorus is not really a metal because we get it, well, it kind of is, but we get it from non-metallic sources. We mine for gemstones. Those aren't metals, but those are things that people mine for. They're very valuable. All right, the next section is on mining methods. So you should know what the mining methods are. In this figure and caption, it shows the two main types. This is strip mining, and this is subsurface mining. So strip mining is literally just bulldozing off top layers, and that's your ore, and you like smelt it or do whatever process you need to do to get the minerals that you're looking for out of it, and just keep digging deeper and deeper, make a big hole in the ground. Versus subsurface mining, which is what a lot of people think of when they think of mining. That's like the old-fashioned mine that goes deep into the earth, and then miners, extract minerals from seams, like coal miners or gold miners or things like that. You should know strip mining. You should know what overburden is. Overburden is literally the stuff that is on top of what you're looking for. And so it's kind of like, the name kind of means like it's a burden. It's a material you don't want, and it is over what you are looking for. Acid drainage happens from a lot of mines because, like let's say in a strip mine like this, if you expose a coal seam that hasn't been exposed to the air before, and the water will start to get on it and it will mix with the sulfur inside it and make sulfuric acid, just like in the clouds and in acid rain, only this happens at the surface and then that water runs off. And so you get acid drainage from mines like that. And then there's also leachate in mining. It's different from the leachate in landfills because this leachate happens from aerobic reactions. So it's when stuff gets exposed to air that it will start reacting now instead of it's been buried for millions of years or whatever. And so this is a form of a water waste though. Leachate is always liquid. All right, subsurface mining is the most dangerous. This is mainly because of cave-ins and things like that, but it is the least environmentally harmful because it's not disturbing things on the surface. It is environmentally harmful, but it is less harmful than strip mining. It does cause black lung disease in miners, especially coal miners. They get that from breathing in heavily particulate-laden air for the entire time they're in the mines, gets in their lungs and causes black lung disease. This is a picture showing acid drainage contaminating a stream. And this is an interesting case. There was actually a mine underground that caught on fire, and it just it's still burning to this day. It's been burning for decades, and they had to evacuate all the people out of this town in Pennsylvania because of these underground fires that were burning constantly. This picture here shows an open pit mine, which is basically a type of mining. So you should know open pit mining, which is digging a big hole. It's kind of a variety of strip mining. And this, when it's used to get something like granite or shale or other rocks like that, we call it a quarry. So it could be an open pit mine or it could be a quarry. We do have an open pit mine near Charlotte in Kings Mountain, and they actually are mining for lithium. So all of the lithium ion batteries that are becoming so important to green energy in terms of electric cars or power storage from renewables, there's a big lithium mine not that far from here. Placer mining is like the old-fashioned panning for gold. So that would be, basically going into a stream, picking up a bunch of sediment and kind of shaking it around in the water, and the heavy metals will fall to the bottom and you let the sediment go out. There's also something called mountaintop removal, and this is a incredibly damaging form of mining where basically it's exactly like they say, they remove the top of the mountain. And how do you recover from that? How do you build that back? You can't. It's terrible. And here's a picture of it right here. This is a mountaintop that's been removed. So these were mountains, and now they're just sort of flat mesas. It's pretty terrible. So you should know the problems in here in this section. You should know some of the problems with mountaintop removal, and there are a lot of them. There has not been an FRQ on mountaintop removal yet, but I would not be surprised if there wasn't one anytime, because it is a pretty important topic. This is basically a science behind the story, talking some more about mountaintop removal. And it tends to be entirely in the Appalachian Mountains. So from, Georgia, South Carolina, up to Pennsylvania, and those regions, a lot in West Virginia. All right, here on page 656, you should know another thing that they can do is mining in the ocean. So there are lots of minerals in the ocean. They're dissolved in the water and they're in the sediment on the bottom. And it can cause possible devastating harm to aquatic habitats if we go after those minerals. The way you get it is by dredging the minerals from the seafloor. And we talked in our fishing unit about how devastating dredging is to the aquatic habitat. This is not in your book, but you should know what UNCLOS is. It's an international treaty regulating ocean mining. And this basically says what countries can go after what minerals where in the ocean. Okay, and then another law that two more laws you should really know, that's what this is all about, is legislation. You should know the idea of reclamation. And this is basically restoring the site to an approximation of the pre-mining condition. And so this is an area that has been reclaimed after a mine. It looks pretty good. So, feels like everybody should have to do that. But another law you should know is a general mining law of 1872. This law is still on the books. Congress can repeal laws. They repealed the Homestead Act, but they have not repealed this law yet. It is still in place, and if you have a mine operating under the General Mining Act of 1872, then you do not have to do reclamation of your mining. And I think that, a lot of corporations and industries don't want to do reclamation. It's expensive. And so they are happy to have this law not be repealed. Another law that you should know is, I think it's SMCRA is how people say it, the Surface Mining Control and Reclamation Act. And this is for coal. It basically talks about how you should reclaim coal mines, and companies are required to put money up ahead of time, ahead of mining, for reclamation after the fact. So that most of the stuff on that law is right here. All right, and then on this page, we're talking about the environmental impacts of surface mining. So this is the strip mines, the open pit mines, all of those sorts of things. Number one, habitat destruction. Massive habitat destruction. You are fragmenting habitats. You are flat out destroying stuff because you're just scraping it up. There's a lot of erosion. Erosion goes up because you've got all this loose material. It blows away in the wind or it gets washed away when it rains. You can get sulfuric acid in streams, and this would come, like I was talking about, from open pit coal mining and things like that. There are toxic air emissions. This stuff has not been exposed to the air in thousands or millions of years. And when it is exposed, there are lots of reactions that happen, oxidation occurs, and it emits a lot of toxins into the atmosphere. There can also be cyanide in water sources. Gold mining uses cyanide to refine the ore, and cyanide is a poison. And so it's just a waste product of gold mining, and a lot of times it often goes out into the water. There have been examples of cyanide getting into a lake and killing all the fish. So it's really damaging. And in certain areas, it can break pipes and sewers. You get erosion, you get shifting and things like that, and it can break pipes. Another problem is slag. This is a word that means toxic heavy metals. And then tailings, which are the things that basically it's kind of like mine refuse. And these are the primary cause of water contamination in mining operations. So the toxic heavy metals, those are things that they don't want. They mine the ore, they get the metals that they want. This is stuff they don't want, and it ends up in sort of like a refuse pile. And a lot of times it will erode into a water source like a river, or it will just get rained on and the minerals will dissolve into the water and go into water sources. So this would be, if an FRQ asked you what's the most harmful impact from, surface mining or something like that, you would want to talk about water contamination from slag and tailings. Another interesting case study was in 2015, which was the Animas River in Colorado. 3 million gallons of toxic mine water spilled into the river during an EPA cleanup. So this was an old silver mine near Durango, Colorado. It was actually closed in 1920, and it was designated a Superfund site, and the EPA was cleaning it up, and one of the containment ponds broke its barrier, and then the 3 million gallons of the mine water went into the Animas River. It turned bright yellow. It killed a bunch of fish and animals. It was pretty bad. And I have a personal connection to this because when I was a kid, I actually went to Durango on a vacation, and I went whitewater rafting in the Animas River, and it was beautiful. And so that's just an example of a place that, was once pristine and has now been ruined. And I think, one more thing. Oh, sorry. The last thing at the end of the chapter, table 23.1, it talks about minerals and the recycling rate in the U.S. So you should know what the most recycled minerals in the U.S. are. Gold is probably the most recycled, and then iron and steel, and then it goes down from there. And that's it, chapter 23.